Hello everyone, hope you all are fine. Welcome to Shoros's classes. So today we are in our session of tomato problem solving. So we have chosen the book of Tomato, Test of Mathematics at the 10+2 level, which is very important for aspirants of I.S.I, CMI as well as Olympiads. So as I have already mentioned that I.S.I publishes this book Test of Mathematics at 10+2 level with the past year questions and also with some extra additional questions that are very important to develop concepts in mathematics and to develop a clear insight and vision of mathematical problem solving. So every aspirant of I.S.I CMI must have this book. It can be easily purchased from Flipkart or Amazon, or it can be easily purchased from Flipkart or Amazon, or the study materials of Shorov's classes are one of the best and exquisite qualities to help you in I.S.I CMI entrance examination. So today we are back with another problem solving session known as the objective problem solving session. So the test of mathematics at the I.S.I or CMI entrance, the paper is usually divided into two parts. First part contains objective problems, so you have to attempt 30 objective problems worth 4 marks each, and then comes the subjective problems, and to clear the exam you must have to qualify in both subjective as well as objective. So many students, what they do is, what I always recommend students is they stress on the subjective part more. But I want to tell you that stressing on the subjective part is of no use unless you clear the objective part. So I have laid emphasis on the objective part, and therefore I have laid emphasis on the objective problem solving session rather than the subjective much. This is because clearing the objective is necessary. If you don't clear the objective, your subjective papers in Indian Statistical Institute will be thrown away, will not be checked, or will not be even touched. So for the objective, you first need to qualify the subjective part of the examination, and so we are back with tomato problem solving session, objective portion. And the first question of today that we are going to deal with is the number of ways in which three non-negative integers are chosen such that n1 plus n2 plus n3 equals to 10 is option A 66, option B 55, option C 10 cubed, or option D 10 factorial by 3 factorial into 2 factorial into 1 factorial. So these are four options, out of which only one option is correct, and I give you just 2 minutes to solve this question. So if you just do the question by yourself, you must do it within 2 minutes. This is because every question, MCQ question in I.S.I is allotted 2 minutes. The faster you do, the better you gain objective in the later parts. So the given stipulated 2 minutes is over, and now I will solve the problem. So I'll just repeat the questions. The number of ways in which the three non-negative integers are chosen such that n1 plus n2 plus n3 equals to 0 is option A 66, option B is 55, option C 10 cube, or option D 10 factorial by 3 factorial 2 factorial 1. Now before solving this question, we need some tricks and we need some ideas or intuitions to solve this. So let me discuss a very important concept before solving this question. The important concept that lies in solving this question is known as partition. It means that I have to partition 10 into 3 parts so that they just sum up to 10. Okay, so that's the underlying principle of the question. So I need to distribute 10 balls. So I have 10 balls. I have to distribute it into 3 boxes. So in how many ways can I do that? Now since n1 plus n2 equals to 10, so n1 plus n2 plus n3 equals to 10. So what is the natural way to do it? And they are non-negative integers. So what is the natural way to do it? So let's take n1 equals to 0. With n1 equals to 0, how many does it have? Then the equation becomes n2 plus n3 equals to 10. If n1 equals to 0, then 1, 9, 2, 8, 3, 7, 4, 6, 5, 4, 4, 3, 3, 2, 2, 1, 1, 9. So remember that if n1 equals to 0, and of course 10, 0 and 0, 10 are also solutions. So it has given non-negative integers, so these are the admissible solutions. So if n1 equals to 0, how many solutions do I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if n1 equals to 0, I get 11 solutions. Okay. Now if n1 equals to 1, how many do I get? If n1 equals to 1, then for n1 equals to 1, I need to just, so I just want to list it out the solutions. So first for n1 equals to 0 it's 11. For n1 equals to 1 it is, what is this? So if n1 equals to 1, then n2 plus n3 is 9. The equation becomes 9. So it's 0, 9, 1, 8, 3, 6, 5, 4, 6, 3, 2, 1, 0. So 7, 8, 9. So how many solutions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many solutions? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9, sorry, not 9, there are 10 solutions actually. 0 to 9, that is 0, 1, 2, 1, 2, 3. Sorry, I missed the 4 part. So here 4 is to be paired up with 5. I missed writing the 4. So there are all total of 10 solutions. Now you get a pattern here. Now if n1 equals to 1, then 10 solutions. If n0 equals to 0, then 11 solutions. Now can you tell me that if n1 equals to 2, then how many number of solutions will this equation have? Following this pattern, of course you are going in the right track. The number of solutions will be 9. So in the next step, the number of solutions will be 9. Why the number of solutions will be 9? Just observe that if I increase 1 here, then every step in this must be decreased by 1. Observe the following fact that if I increase by 1 here, what is if I make n1 equals to 2? So if I am making n1 equals to 2, I am just increasing by 1. And to increase by 1, I have to decrease by 1 each time in the n2 portion or in the n3 portion. And if I decrease that part, what will happen? This 0 becomes minus 1. But minus 1 is not admissible, and therefore all the pairs will remain except the minus 1 pair that will decrease. So how many solutions? 9 solutions. Following similarly, then the next part I can get 8 solutions. And dot 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 up to 7, 6, 5, 4, 3, 2, 1. And if I add this, I will get the number of solutions. So I hope that you are not clear with the concept right now. So let me just make another useful illustration so that you can be clear with the concept. Suppose I have 3 boxes and I have 10 balls. My work is to distribute the 10 balls in those 3 boxes, where any box can receive nothing. So what do? In the first box, I place a ball. Say I consider case 1, in the first box, I place 1 ball. Then how many ways can I fill the 2 boxes? 11 ways. As I have always said that the number of ways is 11. Now, what if I place n1 equals to 2 balls? Now, what is the concept of the strategy of placing 2 balls? How would you do? Would you collect all the balls again or just shift 1 ball from 1 box to n1? Exactly, that we are doing. We are just shifting 1 ball from 1 box to n1 so that it becomes 2. Okay, now if the box have 0 balls, if a box suppose has 0 balls, we cannot transfer, we need to transfer it from the other box. And therefore, there is a case where 1 box has 0 balls and therefore the number of solutions is 10. In the second case, again if we increase it, then the number of solutions become 9 by similar logic. And this is the way we solve partition problems of 10 into 3 parts, of 10 into 4 parts like this. And so what is our final answer for the problem? The final answer is 1 plus 2 plus 3 plus up to 11, which sums up to be 66, a well-known formula which we all know. And hence, by tomato question, the correct option is option A. Now I hope that you realize that how important the concept that we have discussed. So this concept of partition is very important in the fields of combinatorics, in the fields of number theory, and in solving questions of I.S.I. Partition is a very hot topic and a very most favorite topic, I must say, near to heart of the I.S.I entrance exam paper setters. So I recommend you to go through this video once again and just see this concept again and again and try solving more problems on this. There is a bunch of problems listed in Tomato on partitions. So just see it, recognize it and solve it, because that will help you the most in problem solving. So now it's time to get to our third problem of today. So this is the second problem for the day. So it says that the number of terms in the expansion a plus b plus c plus d whole power 2009. So that is 2009 given there in case you are not getting it with the color contrast, is 2009 C4, option B, 2012 C3, option C, 2013 C4, option D, 2010 to the power of 4. So I give you 2 minutes to solve this question, and please try it on your own first. Don't just leave it for the solution. Okay, so the stipulated time that was meant to be given is over. So now I will solve this problem, and if you couldn't solve this problem, just learn the concept, that is enough. Now, A plus B plus C plus D whole power 2009. So what is the speciality with the number 2009? So if you are solving an I.S.I problem and you get a year like this 2009, 2017, you can be pretty sure that the problem was from a paper of 2009. So I can be pretty sure that this problem is from 2009 paper. You can check it out yourself, either in BStat or BMath, this question is present. I.S.I professors or the I.S.I question setters have a very interesting way to utilize the year number in their question. So before going to appear for I.S.I exam, know the numerical properties of your year properly. This is because your year might have some exciting and fascinating numerical properties which can be exploited in subjective and objective questions. So let's get back to the question. So A plus B plus C plus D whole power 2019. Now how can we visualize this? So if I visualize this, I need a 2009 dimensional plane, which is practically impossible to visualize and even construct. So how can I visualize this? The visualization goes like this. Suppose if I expand this and write, then what will it become? So 2009 times I write A plus B plus C plus D and multiply it together. So in case you cannot see it, I just shift it a bit so that you can see things properly. So this is equivalent to writing 2009 terms of A plus B plus C plus D. Now what is this thing similar to? So let's get into the core concept. Suppose you have 2009 balls in your hand and you have 4 boxes. In how many ways can you place 2009 balls in those 4 boxes? In how many ways? The boxes can contain 0 balls also, the boxes can contain n balls also, 2009 balls also. So in how many ways can you place them? So let the number of ways be x. Okay. Now observe that this problem, the number of terms in this problem is basically the same as the number of ways of dropping 2009 balls in 4 boxes. So I hope you didn't get this, so let me repeat it. The number of terms, so get this concept very clear, that number of terms here, 2009 terms, is equivalent to the number of terms, to the number of ways in which you can distribute 2009 balls in 4 boxes. Why? You can clearly see the 4 boxes A plus B plus C plus D. So these are the 4 boxes and these are the 2009 balls. So in how many ways you can attach coefficients to A, B, C, D? In the number of ways in which you can distribute those 2009 balls in 4 boxes. So in case you just don't understand, you can just try it out experimenting and exampling by yourself so that you can just really find the essence of this problem. So in how many ways can you distribute 2009 balls in 4 boxes? Just like the previous method we have learned, that is 2012 C3 is the number of ways. So what is the answer? Then the answer according to the question paper is option B. So as you see that partitioning boxes in balls and partitioning the balls in the boxes serves as a very important problem solving principle. So this is basically known as the partition principle of problem solving. So I have used partition principle in both the questions. So I hope that you got the crux. The crux is to distribute 2009 balls in 4 objects, or to distribute n balls in R objects, n balls in R boxes. So just remember this thing, try practicing problems more and more and more on this, so that this concept gets mixed with your blood, and so that it comes out with the flow, just how it came out with me when I tried solving this problem, and just how it came out with the qualifiers of I.S.I entrance examination. So now we will get to our 4th problem of today. So we will now get to the 4th problem. So we get back to the 4th problem of today. So the problem says that if under finitely many row operations we get, this is a matrix, x 5x 1 3 minus 2 minus 2 minus 2 3 2 0 0 21 1 minus 1 minus 14 0 4 by 3 and 4, then what is the value of x? So is it 3 minus 3 minus 1 or 2? So I give you 2 minutes to solve this question, because in I.S.I you will get 2 minutes per question to solve a proper problem. So I just lend you this time. Okay, so the stipulated time that was lended to you for this question is over. And now if you could solve this question, then it's very fine. You can just tally with the answers, and if you couldn't, just see the solution that I did to solve these problems. Now, in general, this is a particular problem that appeared in I.S.I examination, in the recent I.S.I examination. I'll just give you the concept in how to generally solve these types of problems. So in general, if any matrix is given, how will you solve such types of problems? I can show you. I'll show you. So that's my aim of giving the problem today. So you have seen that there is a term here which is known as the row operation. Okay. So what is row operation? A row operation is an operation on a matrix that is defined in a matrix. So suppose if I have a matrix like this, say 1, 2, 3, 4, 5, 6, 7, 8, 9. And I say I apply a row operation on say row R1, I increase that 3 times R1. So what did I do? Every elements of row R1 is increased 3 times. So the resulting matrix becomes 3, 6, 9, 4, 5, 6, 7, 8, 9. Remember that when you are applying row operations, don't use the equality sign. This is because this matrix is never equal to this matrix. So use the arrow sign. Now what more I can do? Suppose I want to add the elements of row 1 and row 2. Okay? So the resulting matrix becomes 7, 11, 15, 4, 5, 6, 7, 8, 9. Again, never put an equal to as because these matrices are not equal. So these are basically called the row operations. So what can I do? I can multiply by a row by a constant. I can add 2 rows or I can subtract 2 rows. Okay, so subtract 2 rows usually basically comes from here. So I just multiply a row by -1 and just add those 2 rows. Now observe the following fact that you will get this later in a theorem form that, and remember it as a very useful result, that if matrix A is row operated to form matrix B, then the determinant of both the matrices are the same. You can check it out yourself by these examples. The proof is now not in the scope of your syllabus. So you just remember it as a fact. So if a matrix is row operated to form another matrix, then the determinant of both the matrices is same. Now I will utilize that concept to solve this problem. So how can I do this? So the determinant of both the matrices is same. So the determinant of right side is, what was the matrix? X, 5x. 1, 3 minus 2, 2 minus 2 minus 2, 2. So this determinant is same as 0, 0, 21. 1 minus 1 minus 14. 0, 4 by 3, 4. So since the determinant is same, what can I do? So I just expand it. So x into 3 times 2 is 6 minus 4 minus 5 plus. So that becomes 1 times 2 is 2 minus 4. Plus x times 1 times 2 is minus 2 plus 6, which equals this matrix. So 0 and 0 multiplied do not produce any result. So I just get 21 into 4 by 3 minus 0. So here what I get is 4 minus 2 is 2x minus, so it becomes plus, so 4 minus 2 is minus 2 plus 10 plus here it becomes, so what does it become? It becomes 6 minus 2 is 4, so 4x, 3 7s are 21, 7 4s is 28. And 4 plus 2 is 6x, so 6x equals 28 minus 10 is 18. And hence x equals to 3. So we see that this was basically a very simple problem if we know that what matrix transformations are. So row transformation is just includes 3 steps: multiplying a row, adding 2 rows and subtracting 2 rows. And just remember, now the proof is out of the scope of your syllabus, and just remember that the determinants of both the row operated matrices. So if A is a matrix in which you have applied row operations to reach B, then the determinant of both the matrices must be same. So that's all from this session. So you have all learned very important and nice concepts in this. So I recommend you again to solve these, utilize these concepts and solve this problem. So mathematics must always be studied with pen and paper, and I request you to sit before any YouTube video of Saurabh's classes with pen and paper to get the maximum results. And as soon as you learn a valuable concept or get a valuable tip or get a valuable suggestion, try to utilize that in future problems. That will help you to increase the creativity, and that will help you to increase your problem solving attitude, which is very important in mathematics. Remember, Indian Statistical Institute entrance examination takes only those students who they find have potential in mathematics or aptitude in mathematics they are needed, and their question paper is best for that purpose. So seeing just examples, reading lots of books is not the only solution to your problem. The only solution to the problem of qualifying is you must practice lots and lots of problems. You can get study materials from Saurabh's classes. You can practice those, as only test of mathematics is not self-sufficient to qualify I.S.I. You need to get into more problems, and for that exposure, I guess Saurabh's classes is one of the premier institutes that can get into your I.S.I. and accomplish your dreams. So that's all for today. Stay fine. All the best for your exam, and thank you.